let's talk about lights and horns. So lights, there are different types of light bulbs, who knew? They all have designations. So 1157 is pretty common, 3157 has replaced some of these, 194 would be our little license plate light bulbs or marker light bulbs. So all these designations mean something, and oftentimes you'll find charts like the one in the chapter of the book that shows the amperage and wattage that would flow through these bulbs. And these bulbs are all meant to operate at 14.5 volts. The entire car is meant to operate at 14.5 volts. Why, you might ask? Well, we have a battery that has 12.6, but when we're using the car, for the most part, we're driving down the road, the charging system is operating, and our average is somewhere around 14.5 volts. So these bulbs are all meant to create light at that voltage. And you'll notice if you turn your headlights on and then start your vehicle up, they're actually brighter once the vehicle's running because there's more voltage behind the circuit, pushing more current through the circuit. So more voltage, more amperage means more wattage or more work being done. And you'll cover some of that stuff in this week's lab. We have a single filament bulb on the top, a dual filament bulb on the bottom. These bulbs with two filaments are often used for stop lamps and tail lights. So you turn the key on, you've got lights in the rear of the vehicle for safety, so at nighttime people can tell you're there before they run up on you. And then the light will become brighter when you step on the brakes. This filament closer in is going to have a more directed beam of light and will be brighter. Sometimes both filaments will be lit at the same time. Sometimes it'll actually alternate between the two filaments. Just a few different looks there, different types of contacts. We don't use the barrel style bulbs very much anymore. Most of them are wedge style these days, or actually have terminals on the back side of them. A couple of our 3057 bulbs, these would be our wedge type. They just force right in like a wedge, and they have these little retainers on them to hold them in there. The difference between these two, 3057, 3057 NA, natural amber. So this is referring to the lens color. Here is our halogen bulb, and this one has failed. The filament has burnt up and fallen down into the bottom of the bulb. When we deal with a halogen bulb, there's really one major thing that we want to be mindful of is when we're replacing one, or if you have to take one out of an assembly for some reason, make sure you don't touch the glass with your hands. If you get oil on the glass, these bulbs get so hot that the glass will actually melt, because as that oil starts to superheat and vaporize, it damages the glass, letting the special gas that's inside of the bulb there come out, and then the filament can burn up, or sometimes the glass will just pop and explode. If you do touch the glass, an alcohol wipe would be enough to clean your oils off of it, and so if you accidentally touch one, you can still salvage it. You just need to find an alcohol wipe. Here's a tech testing a bulb, and the bulb is being tested for resistance, and it should have some. A bulb that has no resistance or zero would be a short, and that would mean no resistance in the circuit, and we'd pop a fuse or burn up a wire. A bulb with OL, outside of limit or over limit, would be an open, and that bulb just won't work. And this one showing 1.1 ohms of resistance, so that bulb is what we would expect to be in good shape. That resistance is going to skyrocket, however, once the bulb is shining, because the filament has become really hot, and heat is one thing that will add a lot of resistance to a circuit, but the circuit is built to work under that circumstance. If you looked at my email, or if you were one of the students that attended office hours, you'll have found out that there is another document that has all these wiring diagrams in it. So if you want to be able to switch back and forth, because I know that it's not as big as some of us would like, or maybe not zoomed in certain places as much as we would like, you can pause this video and kind of cycle between the two documents if you would like to. And this is a really simple lighting circuit. This is our headlamps. And one, we've got hot at all times. So that means the fuse up in the fuse panel has power supplied to it regardless of what my key position is. So that way I can turn headlights on without having to have the key in the accessory or the on position. So you'd expect to see voltage down here to my switch no matter what. Unless I had a dead battery or a disconnected battery, I should have voltage here. There's a circuit breaker in here because sometimes when a filament burns up, it'll sometimes create a short circuit, so they're trying to protect everything there. The circuit's drawn in its normally at rest position, which headlights are normally turned off. Here's my connector showing which way my terminals go, male on top, female on the bottom there. I have my circuit number, the color of my wires, connector numbers, and again, I'd covered this once before, but these dashed lines around components mean that it's part of a larger component, or I guess component's really all it is. So this just means that this dimmer switch here must be able to do more things. Maybe it can also operate the turn signals, maybe it has an auto light feature, maybe it deals with the windshield wipers, who knows. We have a high beam indicator, and then I've got dual beam and high beam. So this would be an old vehicle with the old what were they called? I think I've got the slide here. Oh, seal beam. Thank you, me. So this would be the old seal beam style, like this. So when we're in low beam, just one of these would be turned on. When we're in high beam, both of them are on, and the one in low beam is on brighter because the high beam one is brighter than the other. So that's what this is showing here. I have a splice, I have my grounds, and the two headlamps have different ground locations, and the indicator has different grounds. So in this case, if ground 302 went bad, the customer would come in and say, my high beams still work. I can tell a brightness change when I hit my dimmer switch and turn on high beam or turn on low beam. But the indicator on my dashboard doesn't show up. The wise technician could look at this diagram and narrow down the few things that it could possibly be. It can't be my dimmer switch because that's working. It's switching my current pathway from low, just like that, to high, where some of it goes through this, but we also have the opportunity to go through this one too. So right there's my high beam. I have two lights on, in this case, on each side. So if that dimmer switch was bad, then I wouldn't have the ability to switch between high and low. If my headlight switch was bad, the headlights wouldn't turn on or would stay on all the time. So we're pretty much limited to just this part of the circuit. Maybe the bulb went bad, or the ground. See what I'm saying? If ground 401 went bad, that would only control one side, so only one side of my headlights would turn off, or would be inoperative. The other side would be fine. Sealed beam. These are old, so this is like this style here. These would be replaced. If the bulb burns out, that entire glass unit gets replaced. I think Jeeps were one of the last holdouts for that situation. Nowadays we use these composite headlamp assemblies, and composite just means that it's made out of different types of plastics. So composite, here we are. The composite will allow us to replace one of these halogen bulbs, just like that, so that's replaceable. The idea is that it's cheaper and, well, one, brighter, but two, also cheaper to just replace the bulb in the entire assembly. However, this assembly costs way, way less than even one of these bulbs do in many cases. Some of these bulbs can be $40, $50, $60. Alright, now I'm hopping around. This is what we see in most vehicles, this plastic composite headlamp bucket. And oftentimes now a front bumper cover, the plastic fascia, will have to come off to get one of these out and then to be able to access the bulb on the backside. I know, genius, right? So here's a tech handling the bulb with care. There's a look at one way that these might be held in. These often have little locating tabs on them, One, to help you not put the bulb in upside down so that the connector and the lock will go on the right way, but just be patient. Often it's really wise to pay attention how the old bulb comes out so that you can get it back in, because I've definitely struggled with these a few times in the past. And this is what it looks like on the car. There's this little hat over the bulb right here, and that's so the light is reflected back towards the back of the bucket assembly, and then it's reflected outwards. Instead of having one really hot point of light, it diffuses the light and tries to give us as much radiation of that light and visibility as possible. There would be our HID. So when we're using HID, we need an igniter, because this bulb is more like a fluorescent light. It needs alternating current to really spike up a crazy voltage inside of it to get the gas to excite and start letting off light. So this igniter ramps voltage way up and can shock you, electrocute you. There's lots of warning signs and stuff, or stickers put on those. There's one of those HIDs, extra bright, bluer, really annoying when you're driving in the other direction, but that doesn't seem to stop anybody. These should only be on vehicles that came with them stock from the manufacturer. If someone has done an aftermarket headlight lamp switch, main state inspection dictates that fails, and I felt great every single time failing someone for that, because usually the lights are way too bright and it pisses me off when I'm trying to drive at night, so I was happy to tell them to where their sticker could go. This should be, when it loads, we have a video of one of these igniting, which is kind of cool. I'll put it on loop so you can watch it happen a couple of times. So there it is, it ignited the first time. And what's happening here, and it'll reset itself in a moment, is there's an incredible voltage that's created. You'll often see it looks like a flash lights up and then it dims back down again. This, they cut the current flow off as soon as the gas ignited, or excited, because it's not really on fire, it's just putting off light energy. But this is what's happening. I just think that's kind of cool. This is what it looks like when we have our ignition. Up top we have voltage. So it looks like our maximum ignition voltage is 23,000 volts, 23 kilovolts. Yikes. Here's our amperage. We're maxing out at 12 amps. And then once the gas is excited, they do a little warm-up period, and then we start to go into a steady state, or this is still going positive negative, so it's alternating current voltage up at the top, and we're around 85 volts. So even while that vehicle has the headlights lit up and it's just sitting there chilling out, you can still get electrocuted by this. 85 volts AC is more than enough to let you know what happened. Even though it's only at 0.4 amps, half of a amp of AC voltage is enough to stop your heart. So just be mindful and careful when you're working with this kind of stuff. There's lots of procedures. That's one of the reasons why they only want these in stock vehicles, is so that there are manufacturer written procedures that explain to you how to go about servicing the systems, so that you don't get bit by something when you're just expecting that you're doing a headlamp replacement or something of that nature. Because this is just a big gas chamber and we don't have two filaments to light up to change the focus of our beam. Think about like a mag light flashlight. You screw it one way, it's real dispersed. You screw it the other way, it's real focused. High beam, low beam. High beam's focused. Low beam's really dispersed. So what they will do with these is there's an electromagnet in the bottom, and it actually changes the position of that chamber up and down. There will be a little fan in the bottom there too to keep the coil nice and cool, because we're sending current through that at all times if we've got high beams turned on. And you can see when the high beam turns on, it really focuses it, makes it nice and bright for us. Here would be our halogen, and we just have two different filaments. The same idea is true. We light up the filament that's tucked further into the bucket when we're trying to create high beam, and then this situation actually pivots. I couldn't find one that would move online, but it actually does a pivot, and that's how it can change the high and low beams, different chambers there. Lots of people like to replace their bulbs with LED bulbs, which is fine. Most of the new LED replacements actually work pretty well, as long as you don't cheap out seriously on them. The point of LEDs that's really nice is they flow really low current, so we would get slight marginally better fuel economy. They're bright. Some people like them because you can change colors, which is wicked illegal. The issues with these is because there's so little current flowing, sometimes where the circuit's meant to flow higher currents, the electrons will find another pathway to ground. And I once had a Fiesta that someone replaced their taillights with these LEDs, and when I turned on, and what they came in with, the concern they came in with, which is kind of interesting, was when my cruise control doesn't work at nighttime. It's just like, what the heck am I supposed to do with this? So cruise control doesn't work at nighttime. I went around, drove the vehicle. It was daytime, right? I'm at work. Drove the vehicle. It works totally fine. Like, what the heck could they be talking about nighttime? And I'm sitting there looking at the car, trying to figure out what options it had. It didn't even have auto headlamps, so it's not like that it had a sensor or any kind of computer control to turn lights on when it got dark enough. It just had the off or on or marker light options. And I was thinking about cruise control and how it works, and you got your button that turns the cruise control on, then you can set your speed, and you can accelerate and coast, you can turn it off, and that's all buttons up on the dashboard. And I can't imagine like those aren't light sensitive. And then I thought, the brake pedal, they put the safety feature in there. If you hit the brakes, then the cruise control turns off because you're obviously not wanting to cruise anymore. And with the scan tool, I pulled up some PIDs and looked at the information and saw that when I turned the headlights on, the body control module that had the PID in it for the brake pedal position sensor showed that I was pushing on the brakes. And what was happening is the current that wasn't flowing through the LED was backfeeding through the brake circuit, the brake lamp circuit, which is right there next to the illumination circuit, and caused the computer to see a voltage and think that, oh, okay, so the brakes are being depressed, and would deactivate the cruise control. So they can cause some weird stuff, but as we get further and further along with them not being super out of the ordinary anymore, they're getting better at manufacturing these so that they work the way that we expect a regular bulb would. Because it's a diode, early ones or cheap ones, you can put in the wrong way. And if you put it in the wrong way, then the LEDs won't light up. Better ones, more expensive ones, are wired up so that it's going to work one way or the other. That's not supposed to be in there because I don't want to talk about that. I'll look at the different types of bulbs and what the benefits and losses are to them. Basically, they're saying that an LED is the best out of all of it. Nice and bright. The amount of light you get per wattage is really good, so like really, really efficient. You can see the amperage draw is way down there versus our halogen. Low intensity, high amp draw, not much. Like, why the heck would you want a halogen? Well, because you can see just fine and other people don't hate you, that's why. Projector lenses have become pretty popular. This is what our regular halogen looks like. Here's our projection lens. You can see the fisheye there. Go back, halogen. And then this is really a halogen, or sometimes HID, but it's just single filament. And the way that they go between high beam and low beam is pretty fascinating. So in halogen, that's our difference. There's low beam, and high beam filament would be in more. On our projection, they use this little door, and when you hit the switch for high-low beam, you'll actually, if you're standing outside the car, have the window rolled down at a stop, you'll actually hear this door moving around. And what the door does is it blocks part of the light when we're in low beam, and then allows all the light to come out, and it gets focused by that fisheye and gives us high beam. So that's what the door looks like inside. See it raise up, go down, and then on a wall, look, you can actually see that same shape of the door. High beam, low beam, high beam, low beam. And it's just trying to keep the light below the windshield of oncoming traffic so that we're not blinding someone. That light can be as intense as you want it to be as long as you're pointing it in the correct direction. So that would just be lower than line of sight. Again, you can refer back to your diagrams, but this diagram's there to show a couple things. One is this is our input side of the circuit. Let's go down to our main light switch and make this bigger. So this would be our main input for headlights. I have a lighting control module, so a computer that's just its whole job is lighting. And what I have is a switch showing me different positions. 0 is my off position, 5 is auto lamp, and we'll go look at that in the diagram in 1 second. Just regular headlamps, parking lamps are just my marker lights. So it'd be like when the cops pulled over talking to the other cop and you can see that their markers are on but the headlights are turned off, that kind of a situation. And I like this diagram because it shows, and we will definitely delve into this in greater detail, but it shows how the module takes on this input. So instead of having power and ground for each one of these, power, ground, power, ground, power, ground, it just has power and one ground. And even this ground is shared by other things. That's what the dashed line means. It's at this splice 207, some other stuff piggybacks in there on its pathway to ground and then back to the battery. But what's happening is this switch is a ground side switch. Here's my load, load, load. Here's my power supply, reference, reference, reference. So across this resistor, let's say I put it to auto lamp setting 5. When I do that, current will flow, and this little piece at the bottom is a meter. It's a little voltmeter built into the circuitry of the module. And what it sees is when I'm in the 0 position or off, no current flows, but I'm still connected to voltage. See that? This leads on power, and then the other lead would be on ground somewhere. There's no connection between the power and ground down here. So what we see is that reference voltage, let's call it 12 volts. It's just a clean 12 volts is all reference means. So this reference voltage doesn't get dropped because we have to have current flowing. Think about Ohm's law. I have volts. To solve for volts, I need amperage and resistance. I've got resistance, but I've got an open circuit, so I don't have any amperage. No voltage is dropped. So what this sees is 12 volts when that circuit's turned off. When I turn headlamps on, current flows across this resistance through the restriction. So I have pressure on this side. I've dropped the pressure on the ground side, right? Because we have to drop all our voltage as we're flowing. It's the only resistance to ground. So then all of a sudden this sees 0. So the way that the computer thinks of this is when this circuit's turned off, when this is not connected, I would have a high voltage. Computers are numb, zeros and ones, right? They can really only think about stuff in that way for the most part. We can make it more complicated, but we have to try pretty hard. So it sees voltage high. 12 volts means I'm off. When it sees 0 volts at this one little meter, and that's a different meter and a different meter, when it sees 0 volts, then it goes, oh, I got my auto lamp circuit turned on. Pretty interesting, right? Then, let's go up here to the top. This is my auto lamp sensor over here. And the way that this auto lamp sensor is working is there's a little solid state controller, which means it's electronic. And it is taking in information from, there are 2 sun load sensors. So these are a couple photo resistors. So the resistance changes based off of how much light is present. And you see that there are diodes there to only allow current to flow in one way. So it is doing a voltage measurement there as it does its resistance check, or this could be solid state and just sends back varying voltage depending on how much resistance is here, right? We don't have that part of the diagram. But we're getting this information, and then this little tiny computer is making a decision based off of that, and it sends information to or it grounds out, looks like, right? Because my diode says that current can only flow this way, so it must supply a ground here to allow the lighting control module to know, okay, it's time to turn on the headlights. Nope, it's time to not turn on the headlights. And I bet this thing has a little timer in it too, so if you go under a bridge or through a tunnel, it doesn't just immediately turn the headlamps on, it waits a few seconds before that happens. Let's see, make it small, go to the next one. So this side, we'll take a step back again. This side, where is my thing? Boop. There we are. So this side is my input side. Right, here's my switch, giving some input information there based off of what I'm requesting. And then here is my output. See how I have little switches inside my module? These are probably transistors, which, like I said, we'll get into next week. But these little switches are controlling current flowing to C and E. What are C and E, you might ask? Let's go find out. There's C and there's E. So this would be on a different page of a wiring diagram. And you'll see that when you look at ALLDATA or Mitchell, or even if you get to a manufacturer site. When you're looking through diagrams, often stuff's not all on one page. And this falls back to a time when I first started working on vehicles. It was when the internet was a thing, but it wasn't super useful or reliable. And so what all dealerships had were books. So our service manual was an actual manual, it was an actual book. We had a electrical wiring diagram as well, and it was interesting because at the dealership, let's say I'm working on a F-150. Let's say it's 2008 when I was a student. So 2008, I'm working on a pickup truck, F-150 at a Ford dealership. The manufacturer would only send the dealer 2 books, and they charged the dealer for those books, but it was required you have to have 2 of the wiring diagram for the '08 F-150. They'd send it to you. Well, I work with 12 techs, and what's the chance that there's more than one F-150 in a Ford dealership at the same time? Pretty dang good. So then you're either taking the book and bringing it to a photocopier and making a copy of it, or you're waiting for Jimmy to finish up doing his crazy wiring, rewiring, or his diag, or whatever it is he's doing to the vehicle before you can get that book from him, because maybe the foreman's off in the other corner and there's no way you're going to get the book from him because he's into something you don't even want to look at, so you're just going to leave him alone, right? So this is why this stuff's on a couple pages. But when you look at this, it says C diagram 87.1, so this would be chapter 87, page 1 of that diagram, which is what this would be if we had that book. So sometimes you'll see that stuff in digital forms as well, because they made the image for a book and then they digitized it after the fact, which was the case up until not that long ago, honestly. I just think this is interesting. Most rear view mirrors, you just flip the little thing and it changes the way that the light's reflected, but they have auto darkening mirrors, and all these mirrors have are a rear-facing light sensor and a forward-facing light sensor, and the reason for that is if it's dark up front and light behind you, then you're being followed by a car with its headlights on, and that's about the time that you'd want your mirror to darken up. If it's light up front and light behind, then it doesn't need to darken up, so we can see fine. If it's dark in front and dark behind, we definitely don't want it to darken up, so we can maybe try to see vehicles that are pretty far away from us. And this uses this electrochromic material, and on a mirror, you've got a piece of glass, this electrochromic material with the ion stuff inside of it, another piece of glass, and then like a shiny piece of metal or plastic or whatever, reflective material, and that's how a mirror works. Glass over something reflective, and it reflects back. What they do here is when they turn it on, then ions are taken from these conductive layers and basically just overcrowd this intermediate position in between the 2 pieces of glass. So before, everything's all lined up and light can just pass through no problem. Ions all of a sudden start being attracted and they clutter up, and it just acts to block some of the light. Very similar to what sunglasses do, they just don't let all the light through, and this is doing the exact same thing. It's just turning a little bit dark, making it so light can't pass through as easily. our auto lamp switch. Some vehicles you can choose the sensitivity and how long it waits to turn them on. That's a case by case basis, but auto lights are using information like what we saw here with our auto lamp sensor and modules and computers and all kinds of fun stuff. Here's a look at another auto lamp situation, and this one's definitely going to be a little hard for you to see. I've got a body control module up here on the top, headlamp switch over on the left, and then we've actually got our auto lamp sensor here. And what I like to use this for really is, let's take a look. Well, let's take a look at this. My module is over here. My headlamp switch is here. All this stuff, this will look kind of familiar to you as you get through the lab. Light emitting diodes with a resistor restricting how much current flows through so we don't burn them up. So this is just illumination of my switch. And then ground, because this is a Valley Forge diagrams over here at the bottom. So this is just a new version of what we saw a moment ago, where inside of my module, I've got a resistor and then a voltmeter after the resistor, looking to see if voltage changes. And the same thing is true if I have current flowing through here, then I'll drop the voltage, I'll see 0 in the module, and it's like, okay, I'm turned off. If I move this over on this circuit, which is CLF23, and it's a violet wire, so purplish, then if I move the switch, no current flows, and I open back up to 12. Okay, I'm gonna beat this into you even from a distance, because I think this is the most important thing that we'll learn from this class, is how voltage changes in the module, and we're gonna keep at it, don't worry. On this, I've got an auto lamp sensor and I've got ground to my sensor. And so it looks to me like the same thing is happening as far as there's a switch inside of here that's either opening or closing, changing voltage inside of the module. They don't give us much information in this diagram how this works. I've got a couple signals over here from my climate control, so this is probably my 2 sun load sensor inputs to that system, so it can tell what needs to happen there. But the way that we would diagnose this is, it would probably check to see, do we have connection to ground through an ohms test? Yes. Do I have voltage coming in over here? Yes. Do I have connectivity, like if I do an ohms check from here to wherever that ends up on the climate control module? Is that wire good? Low resistance and an ohms check. Is this wire good? Low resistance and an ohm check. Oh, we've eliminated everything else, so it has to be this. This is how modules and little solid state components are going to be diagnosed, because they don't want us to have to go through and start taking stuff off the board, because you can't test one of these when it's really all put together. You actually have to see like the schematic for this little piece, and then you'd have to take it off the board after you understand what's happening, test it individually, because that's how resistance checks work. So we'll diagnose by process of elimination, basically, is the point I'm trying to make. This is the output for that circuit, and this one has halogen bulbs. There is an HID option, and it would show it in the diagram, so I want to make sure I'm working with the right one. I've got fused hot at all times, and then I've got little microprocessors that are controlling my transistors, which are just electronic on-off switches, kind of like a electronic relay. And like I said, we will delve into this next week in very good detail. But this, you can think of this like a switch, and when it's turned on, it flows current down to my bulbs. And you can see the bulbs are denoted by 1, 2, 3, and 4. So 1 is parking lights, 2 is high beam, 3 is low, and then number 4 over here would be my turn signal in that headlamp assembly. This headlamp assembly is complete. It's showing us everything. That's why there aren't dashed lines around it. This dashed line here is telling me that connector 1509A houses all of these wires inside of it, and this is just the power side. If we look at the ground side, oh look, my 2 ground wires are also part of that connector, and it looks like we go all the way up to 16 pins, so I wonder if there's anything else that goes in that connector too. Be interesting to find out. Okay, moving right along. I don't want to dwell too long with these yet, but trying to make it clear what's going on. Well, I guess we'll look at one thing. So, is that ground 101, ground 106? So they both have two different grounds. And the interesting thing is, it has two ground wires coming off of it. So if this ground corroded right where it went to the body, then none of these lights would work. If just this wire broke, I would still have my low beam and my turn signal. I just wouldn't have high beam and parking lights. So this wire could be broken and someone could be driving around like that for a pretty long time without noticing it. It even denotes my left hand side, so maybe they'd be more likely to notice it because it's on the driver's side. So they might. I've seen many people with passenger headlamps that are burned out that have no idea because it's on the passenger side and they're not really looking towards the side of the road. They're just looking down the mustard there. A block diagram showing a vehicle with, does this one have auto lights? Nope, this would just be our regular headlamp circuit. So this is out of like a 2014, 2015 vehicle. And what I have here is my body control module. It sent information by my headlamp, also by my start-stop switch. So this would be the ignition. And then I've got a multifunction switch for my turn signals. So I guess that's probably why I have that on here. So let's say I want to take a turn. I'm driving down the road, headlights are on, so my headlamp switch sent a signal to the body control module, and the body control module has controlled both of my headlamps by sending a voltage and current flow to my bulbs, and they're all lit up. Everything's happy. Let's say I want to make a turn. So I'm going to do my left-hand multifunction switch. Right, I've got one on the left hand of my column, one on the right hand of my column. Let's see what we're doing. The right hand one is for my wipers. So left hand multifunction switch, left hand turn, I push it. I want to hear tick tock and let's make the thing happen. So that is a direct input. That's what these mean, input, input. A direct input to my steering column control module. This is right in the steering column and it's hooked up to the clock spring that allows me to turn the steering wheel but still have control over the switches and stuff. So there's a module right there that sends a networked message to my gateway module. So this gateway module is there. You see how I'm going from high speed 2 communication network over to the high speed 1. So these are different wires. So this gateway module is just a gatekeeper that's translating from here to there. So switch to my first module, to my second module, to my third module, and actually no, it doesn't even go to that one. First module, second, third, and then it comes down to my hybrid cluster module. So this would be my instrument cluster. It's just a fancy name. Everybody's got their own vocabulary here. And this sends a networked message over these LENs to the actual headlamp assembly, and that's how the blinker is flashed, right? Your brain is just fried by that. These networks, the HS1 and HS2 messages can go both ways. So this module can talk to this one and this one can talk back. On a LEN, this one direction. This is the master, this is the slave. Slave, do the thing. And in this case, if we want to turn left, it'd be slave. Left hand headlamp, I want the blinker to blink, and it doesn't even say yes sir, it just blinks it because it can't talk back. So input to a module communicates to another module, communicates to another module, communicates to another module, and then the output is handled. Why do they do it this way? Well, there's a lot of reasons why the little marker might want to flash. Maybe we lock the doors, maybe there's an alarm event, maybe there is a crash and they want to control it that way, or maybe I just want to take a turn. The benefits to being able to do all of those things seem to be worthwhile. I know we're all questioning that right now. The major benefit to a lot of this is because of all of these computers involved, we can get codes now. Codes can be created for different failures. Let's say the steering column control module pooped its pants. I might get a message, I might have a code in my gateway module saying invalid or no communication with steering column control module, invalid data or no communication. And that doesn't say the gateway module is bad because it has the code in it. What it's doing is it's pointing at the steering column control module saying, hey, I haven't heard from this guy in a long time, or what I did here just didn't make any sense. The ABS module might have that information in it as well, and that would be backup saying I need to go see if I can diagnose this steering column control module or try to talk to it with a scan tool or look at PIDs or something of that nature. That's the benefit of codes. That's the thing where you hear the person say, cars are so easy to work on these days because there's just you hook a scan tool up, it gives you a code, and it tells you what part to replace. It gives you a big old pointer in the right direction, but it definitely doesn't mean that the steering column control module is bad. Maybe a wire got broken, maybe there's a popped fuse, who knows. So this is just a preamble to the video that's going to come up about how cars usually just point the headlights in the direction that the car is pointed, not necessarily in the direction that you're going, but manufacturers are already working and have in production technology that makes that obsolete, basically. So let's take a look at this. Alright, I believe that you should still be able to hear the noise even though I just muted it. It's basically just like fancy music making you get in the mood to listen or watch some headlights move around, but I'm going to try to be quiet for a little while. Just watch this video, and this is in production right now. I think it's pretty fascinating what they're doing with these vehicles. You can see that the actual headlights can be aimed. Using a forward-facing camera to be able to understand what's going on up ahead of the vehicle. So that's a fair amount of technology there. And the idea behind this is that BMW believes that they can, with their superior lighting, because this is a high-dollar car, they can create a better visibility for both the customer vehicle and other traffic on the road. So you can see how we just didn't blind this poor sap driving their Toyota Camry or whatever. You see the pocket of darkness that the car is maintaining. It's pretty fascinating stuff. Now what happens when we're following a vehicle? It's like the thing's getting gobbled up. In the real world view of it, I mean, it seems like it works pretty dang well. You're not getting glare in your rearview mirror, and it's also helping to illuminate the rest of the road for the car in front of you. And it's even following the car around the corner, which is pretty incredible. Now what happens if we have oncoming traffic at the same time? incredible. And the reason why they're so keen on illuminating the sides of the road is in rural areas, right? We don't know anything about that. You have to be worried about deer and other rodents and stuff like that. So trying to keep the driver and their passengers as safe as possible. I think it's interesting. I hope you found it interesting as well. There's a couple more vehicles coming, and it's seen them. It takes it into account, right? And that's really like the best hits. There's a copy of this on the website as well, so you can download that. We're going to go through a vehicle being diagnosed. This vehicle has a taillight fault indicator, so it's has some sort of a solid state processor somewhere in the vehicle that can tell when a taillight is blown out. So in visual inspection of the rear of the vehicle indicated the right rear taillight was out following a virtual diagnosis here. So he said light check. Someone came over and checked their lights. When you pull into a shop, the first thing you're going to do with every vehicle, because you're doing a multi-point on pretty much every vehicle, is check all the lights. No one likes it when you sell them a brake job and then they get pulled over for a taillight being out after the fact. So they saw it didn't work. They're accessing the light. Pulls it out. He moves the bulb and then does a ohms check on the new bulb. I don't know. He probably just looked at the old bulb, saw it was burnt out. I don't know why he's doing an ohms check of the new one. Maybe comparing it to the old one and being like, oh, okay, yeah, this one's definitely good. Who knows? And then he would put the car back together. The thing that and this is right out of your book, the thing the book doesn't say is that the technician verified the repair. I've had it many times where you see a bulb's burned out, you think it's just a bulb. You pull the bulb and the socket out of the assembly and then realize that it's all corroded because there was a crack that you didn't see and it's been filled up with moisture, and so there's all those little green meanies that are growing on the thing causing high resistance. Alright, so whenever you do a repair, make sure you verify it. That should be very basic and is something that just is going to get said over and over and over again. Always verify your repair. Someone's paying money for this stuff. You don't want them coming back all mad because you didn't actually fix it. There's our typical horn circuit. Horns are going to almost always be controlled by a relay because they flow a fair amount of current through them. So we don't want all that current having to go into the wire up at our steering wheel, because that wire would have to be thicker, which is more expensive, and it also has to go through the clock spring so we can steer the vehicle. So that would mean the clock spring's more expensive. That's expensive enough. Also means that the switch is more expensive. You get the point that I'm saying here. So it always goes through a relay. We have two horns. We have a high frequency and low frequency horn. The reason that they use these dual horn systems is so that the horn can be heard whether you're outside of a vehicle or have windows rolled down. The high frequency horn will like really get your attention. Or if you're in a vehicle and you have windows rolled up, the low frequency passes through glass and body panels and things of that nature much better. So they use these dual horns to try to make sure that the horn is audible in the greatest range possible. If one of the horns goes bad, then the customer comes in saying, my horn sounds funny. Like, okay, so does it tell you any good jokes? I'm not sure. The way the horn works is it's basically a speaker with a coil of wire, and when you hit the switch, the coil powers up, pulls the diaphragm of the speaker back, but also at the same time it disconnects these contacts, which cuts off current flow. So then the speaker moves forward. The diaphragm and armature move forward, making contact, allowing current to flow, creating magnetism, and so the thing just sits there and wiggles back and forth like a speaker, making noise. Often mounted on the radiator support in the front of the vehicle. And then here's a diagram also provided for you of a horn system. Our dual horn assembly here. And this is a GM diagram here. So I've got our fuse coming into a relay. I've got my clock spring here and then the switch on the actual steering wheel. But I've got this thing here, this body control module. Why would that need control over the relay? This is going to allow current to pass through my coil of my relay, creating the electromagnetism that closes the switch, sends current to my horn, and the horn honks. So why would a BCM need to be involved? I'll give you a second to think about it, or you can hit pause at this moment if you don't want me to give it away. I'm going to give it away. So that's there, so if you lock the door with your key fob, the little push button on your key ring, then you can get it to chirp, right? Lock once, twice, beep. Okay, I locked my car. Or you just keep pushing it because for some reason you didn't believe it the first time and you want to drive Casey absolutely crazy, then beep, 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 right? Or you hit the panic button, and it beeps in that instance as well. Or if someone breaks into the car. So there's our horn right there. This ground, this is just a symbol for chassis ground, so not a big deal. And then instead of numbers for the connectors, they're using terminal letters, so A and B. So if we looked up a connector view for the horn connector, it would let us know which one's A, which one's B. So if we were testing for power or ground, we'd know, okay, A is the black wire, so that should be connected to ground. B is the dark green wire. Circuit 29, circuit 150. Another horn circuit. Is there anything really that interesting on this one? Oh, I think the interesting thing with this one is it's old enough that there wasn't a clock spring, so there's no airbag in this steering wheel. This just has a slip ring. So this would just be like a brush on a piece of metal, kind of like what we saw inside of alternators and starters. Versus the clock spring, and you see how it even shows that it's part of the inflatable restraint system, so clock spring there. Backup lights. On this one, this shows a nice illustration of two different vehicle options, automatic transmission or manual. When I put the vehicle into reverse, there is a switch on the transmission that allows current to flow to my backup lights. So this would be my range sensor because it is telling the computer what range I want to be in. I'm shifting it mechanically, and there's a valve that moves inside the transmission's valve body. But I'm also shifting it electrically, so I'm giving these computers input to let them know what range I'm in. And then on a manual transmission, there's just a switch on the side of the case. And when you're moving your shifter around into reverse, when you push it over to the side and back, there's actually a metal piece that makes contact and pushes on a switch and closes the contacts to allow current to flow. So I just think it's interesting that you can, I think it's interesting for you to see that oftentimes a diagram will show you two different vehicle options, and you need to pay attention to what vehicle you're working on to figure out which option is right. There's our range sensor, and you can just barely see it, but when you put these range sensors on, the holes are oblong, and you usually install them with the vehicle shifted into neutral, and you have to make sure that they're timed up properly. There's a little notch here and a notch here. They need to line up, and then you tighten the bolts down and you put the little arm on top of that. And then we will end with a couple of videos. This is upcoming technology for Audi. It does not exist right now, but it's what they're working on. Using OLEDs, which are organic LEDs, and some laser technology. And I think this is interesting, where they're getting in more into vehicle automation, communicating with the road and with other occupants of the road, which I think is cool. So we'll watch this happen. Sees a pedestrian, it stops and says, okay, you can walk, and it shows the little footprints there. So if this was an automated vehicle, the customer has someone to, some sort of communication, and saved them from getting smashed by the oncoming traffic. showing the margins of the road. So this is just showing all the different ways in which it can control its disbursement. I don't really know what that means. Marking a pedestrian so the driver can see it, but also it's going to get the pedestrian's attention, being like, yo, I don't want to smash you. And this is really, really actively limiting light to that car, which is crazy. If you get scared driving by 18-wheelers, it actually shows the footprint of the vehicle so you know where you're at in the lane. We've all seen people who can't figure out how to drive past a truck. And off into the sunset. How amazing. And this last bit, I'm going to fast forward a little bit because I think if I remember correctly, some guy has a lot to say. Oh, wait, no. I must have found a better one. This is another OLED. Yeah, there you are. I love Autis. They are so cool. So this is OLED. They call it the Swarm. And there's actually some contention about this. This was in a concept. And they're actually worried that other drivers are going to get so mesmerized by it being like, whoa, that's cool, that it might cause crashes, but who knows. These are just little organic LEDs that can turn on and off really, really quickly, and they're really small, so there's just a ton of them there. But a pretty beautiful idea. It looks like Russian water almost. I was hitting the brakes. Alright, so this ends our lecture for headlights and horns. I hope you take a little bit of time to look at some of those diagrams because we're not really having the ability to work with actual vehicles and work with these diagrams. So take your time, look at some of the stuff, try to make sense of it. And if you have questions about it too, we have office hours at 9 o'clock every Friday. So you can bring up, hey, I was looking at this diagram, it doesn't make much sense. I can share my screen and we can kind of talk through some of that stuff together if you'd like to. So I hope everything's going well for you, and I will see you next time.